Now imagine waking up tomorrow to find out that new smartphones are not being manufactured anymore. Electric car factories are shutting down. AI data centers are not growing anymore. Wind turbines are left unfinished. Advanced fighter jets are not manufactured anymore. Sounds like the storyline of a movie of the future, yet it is not. Today's world does not exist thanks to the supply of oil anymore. Behind almost all technologies defining our time, smartphones, electric cars, missiles, wind turbines, satellites, and supercomputers, there is a group of exotic metals collectively known as rare earth elements. Though most people have never heard about them, these materials form the backbone of the 21st century technologies. What is even more surprising, one single nation has almost complete monopoly on processing these materials from raw form into the form ready for industrial use. While there may be many countries with rich rare earth deposits, few of them have ability to process them into highly demanded materials. So how this happened, how the whole world came to rely on one producer of such crucial components. What would happen if the supply will be cut? Today we will reveal one of the most important and unknown monopoly stories of our times. This is the hidden war for the future of technology. Invisible forces driving the current era. What do you think is the driving force behind the contemporary economy, oil, electricity, and the internet? In fact, it's something much more obscure. The rare earth elements are the 17 metallic elements naturally occurring within the Earth's crust. They aren't rare. Many can be found in abundance in such nations as Australia, the USA, Brazil, India, and some African regions. The issue isn't discovering them, but processing them. They have exceptional magnetic, optical, and electrical properties that facilitate the operation of current technologies. Neodymium produces ultra-powerful magnets utilized in electric motors. Dysprosium helps these magnets resist extremely high temperatures. Europium makes LED screens colorful, and yttrium helps create lasers and electronics. The absence of these minerals would make smartphones bulkier and more inefficient. Electric cars wouldn't work at their full capacity. Wind power plants wouldn't be so productive. And such complex apparatus as MRI and advanced military equipment wouldn't operate efficiently. Rare earths are the essential constituents of the era we live in. Consumers never know about them, but without them, no contemporary device could function. Why rare earths are more important now than ever before. Each time you unlock your smartphone, watch a film, or ask an artificial intelligence assistant about something, you use supply chains that stretch over thousands of miles through various mineral mines and chemicals plants. Rare earth elements have long ceased to be merely industrial materials, but become strategic materials. Each electric car contains rare earth magnets that give maximum effectiveness to its motor. Wind turbines also utilize such rare earth magnets to convert wind energy into electricity. AI data centers use advanced cooling, precision electronics, and manufacturing technologies that depend on rare earth minerals. Similarly, modern military industry needs rare earth elements. Precision-guided missiles, radar systems, fighter jets, submarines, drones, and secure communications satellites incorporate rare earth elements because they give unprecedented strength and durability. Nowadays, rare earths cannot be described as merely a resource used for mining. Instead, they became a meeting point of technology, national security, clean energy, and international economic power. In the times when humanity moves fast towards artificial intelligence, renewable energy, and advanced robotics, the demand for these mineral elements grows faster than ever before. And the countries which manage to gain reliable access to rare earths will determine the future of the entire international economy. How a nation created the world's most powerful mineral monopoly in the 1980s. While the rest of the world was concerned with oil, computing, and globalization, there was one nation investing its money in something completely different: rare earth elements. At that point, most Western corporations perceived rare earth mining as a very costly venture, which was environmentally damaging and not financially beneficial. Mining and separating process was very expensive, produced lots of harmful waste, and offered slim profits. Despite all those disadvantages, this nation did not try to avoid those problems but accepted them instead. The country invested vast sums in mining, exploring, chemical separation facilities, and factories. With state funding, low-cost production, and decades of strategic planning, the nation managed to transform the entire industry. With more products being delivered to consumers, the price of the product became incredibly low. It became harder for competitors from the US and other nations to compete in the economic aspect of business. Most facilities stopped their activity or shut down entirely. Nowadays, this strategy became more complicated than simple mining. The nation has managed not only to control extraction, but also refinement of metals and creation of powerful rare earth permanent magnets. Almost all corporations around the world have become involved in that supply chain. It was cheaper and effective to be integrated into it. This superiority is achieved not because of any sudden market changes, but because of decades. AI, electric cars, and the new mineral rush artificial intelligence can be seen as being composed of software, algorithms, and computer chips. However, behind each successful AI innovation lies the physical world of manufacturing plants, minerals, and infrastructure. Training advanced AI systems requires huge data centers packed with thousands of high-performance computer chips. Building these computer chips needs specific machinery, motors, laser beams, and materials, some of which are based directly or indirectly on rare earth minerals. The same phenomenon takes place in the electric car industry as companies struggle to make longer range and efficient vehicles, which require more high-performance permanent magnets. Wind power generators, robotics, drones, and futuristic humanoid robots put additional strain on already complicated supply chains. This phenomenon sparked the mineral rush, called by some experts a new global mineral rush. Governments around the world invest billions of dollars to acquire the critical mineral resources, develop domestic processing capabilities, and lessen reliance on foreign suppliers. Firms search for new mineral deposits, develop new recycling technologies, and explore new materials. Unlike the oil rush of the past centuries, this competition is not driven by energy but technology. Countries securing the access to critical minerals would get a significant competitive advantage in artificial intelligence, manufacturing, renewable energy production, and economy for decades to come. Can the monopoly be broken? The race for tomorrow. Throughout history, there have been monopolies in different industries and sectors that did not last forever. With innovation and investment in research, any monopoly is bound to face competition and challenges. However, the key question in this case is when it would happen. With new deposits being discovered in previously overlooked regions, mining companies are working on better methods of extraction and environmental protection. At the same time, specialists all over the world are researching technologies that would enable recycling of rare earth minerals from smartphones, electric vehicle batteries, wind turbines, and other pieces of waste that could potentially become some of the most valuable urban minerals. Scientists also look for alternatives to rare earth minerals such as novel magnetic materials, advances in battery chemistry, and motor technology innovations that could lessen the dependence on the particular rare earth minerals. Although it is still under development, it is an important aspect of this matter. Governments are already spending huge amounts of money to build domestic processing facilities, create national stockpiles, and make international deals concerning the matter. While the country that possesses the largest amount of mineral deposits might not necessarily win the competition, the one that will manage to mine, process, recycle, and utilize them the best way would have the greatest chance to succeed in it. If you enjoyed this deep dive into the hidden resources shaping our future, make sure to like this video and subscribe for more cinematic documentaries on global technology, AI, geopolitics, economics, and the forces transforming our world. Every week, we break down the complex stories behind the headlines, explaining not just what is happening, but why it matters and what could happen next. Thanks for watching, and we'll see you in the next documentary.